When a contactor is situated above an electrical panel with a raceway connecting them, and circuits requiring control by the contactor are within a raceway entering the same panel, the question arises whether it is permissible to pull these circuits through the panel and into the contactor, effectively using the panel as a junction box. The understanding is, and it is generally agreed, that this practice is acceptable provided there is sufficient space within the panel for the conductors. This method is employed frequently and without issue, as long as the space requirement is met. From a code perspective, the National Electrical Code, or NEC, does not explicitly prohibit using an electrical panel as a junction box. However, it does impose several conditions that must be satisfied. The primary concern is the available space within the panel. Section 312.8 of the NEC addresses this directly, pertaining to enclosures for switches and overcurrent devices. This section allows for conductors to pass through an enclosure, such as a panel, if the wiring space is not less than that required for the terminals to which they are connected. This means that the panel must have enough physical room to accommodate all conductors, splices, and taps without overcrowding. The conductors must not fill the enclosure to more than 40% of the cross-sectional area of the space for the conductors. Splices and taps are also limited to no more than 75% of the cross-sectional area of the wiring space. The volume of free space within the panel is a crucial factor. NEC Article 314 provides guidelines on calculating box fill, ensuring there is enough space for all conductors, devices, and fittings. Each conductor entering the box counts towards the total fill. Conductors that run through the box without a splice or termination also count, but only once. Each device, such as the switch or receptacle, counts as 2 conductors. Any internal clamps, supports, or fittings also contribute to the box fill calculation. The total volume of all conductors, devices, and fittings must not exceed the maximum volume marked in the enclosure. It is essential to perform a thorough box fill calculation to ensure compliance with NEC regulations. Another critical consideration is the proper termination of conductors within the panel. All connections must be made using approved methods and materials. Wire connectors must be suitable for the size and type of conductor being used. Connections must be tight and secure to prevent loose connections, which can lead to overheating and electrical fires. Furthermore, the panel must be properly grounded and bonded. Grounding ensures that any fault current will safely return to the source, tripping the overcurrent device and preventing electrical shock. Bonding connects all metal parts of the electrical system, creating a low impedance path for fault current. The grounding and bonding system must comply with NEC Article 250. The panel must be accessible for inspection and maintenance. NEC Section 110.26 requires sufficient working space around electrical equipment. This space must be clear and unobstructed, allowing electricians to safely access the panel for troubleshooting and repairs. The working space must extend at least 30 inches in front of the panel and must be at least 36 inches wide. The height of the working space must be at least 6 feet 6 inches, or the height of the equipment, whichever is greater. Additionally, the panel must be properly labeled and identified. Each circuit breaker must be clearly labeled with its purpose. The panel must also have a directory that lists all circuits and their corresponding loads. Proper labeling helps to prevent confusion and errors during maintenance and repairs. When using a panel as a junction box, it is important to maintain the integrity of the panel's enclosure. Any openings or knockouts that are not used must be closed with appropriate plugs or covers. This prevents the entry of dust, moisture, and other contaminants that could damage the electrical components. Additionally, the panel must be protected from physical damage. It should be located in an area where it is not likely to be struck by moving equipment or other objects. If the panel is located in a hazardous location, it must be rated for that environment. Hazardous locations are areas where there is a risk of explosion or fire due to the presence of flammable gases, vapors, or dusts. Panels used in hazardous locations must be explosion-proof or intrinsically safe. In summary, the NEC does not explicitly prohibit using an electrical panel as a junction box, but it does impose several conditions that must be met. These conditions include sufficient wiring space, proper termination of conductors, grounding and bonding, accessibility, labeling, and enclosure integrity. Firstly, ensure compliance with NEC Section 312.8 regarding wiring space in enclosures for switches and overcurrent devices. Secondly, perform a box fill calculation in accordance with NEC Article 314 to ensure adequate space for all conductors, devices, and fittings. Thirdly, use approved methods and materials for all connections, ensuring they are tight and secure. Fourthly, properly ground and bond the panel in accordance with NEC Article 250. Fifthly, maintain sufficient working space around the panel as required by NEC Section 110.26. Sixthly, properly label and identify all circuits and components within the panel. Seventhly, close any unused openings or knockouts in the panel's enclosure. Eighthly, protect the panel from physical damage and ensure it is rated for the environment in which it is located. By adhering to these guidelines, it is possible to legally and safely use an electrical panel as a junction box. Failure to comply with these requirements can result in code violations, safety hazards, and potential liability. It is always advisable to consult with a qualified electrician or electrical engineer to ensure compliance with all applicable codes and standards. In addition to the NEC, local codes and regulations may also apply. These codes may be more restrictive than the NEC and may impose additional requirements. It is important to be aware of and comply with all applicable codes and regulations. When in doubt, it is always best to err on the side of caution and seek professional advice. The consequences of non-compliance can be severe, including fines, penalties, and even criminal charges. Moreover, non-compliance can create safety hazards that put lives at risk. Electrical safety is paramount, and it is never worth taking shortcuts or cutting corners. Always follow best practices and adhere to all applicable codes and regulations. Here's a more detailed breakdown of key NEC sections relevant to using electrical panels as junction boxes. Firstly, NEC Section 312.8, as mentioned previously, is crucial. It states that enclosures for switches or overcurrent devices, like your panel, can have conductors passing through, entering, or leaving, if the wiring space meets specific requirements. The key is ensuring that the space isn't less than what's needed for the terminals to which the conductors are connected. This means you can't cram wires in there to the point where it's difficult to make proper connections or where the wires are stressed. Secondly, NEC Article 314 covers outlet, device, pull, and junction boxes, conduit bodies, fittings, and handhole enclosures. While your panel isn't strictly a junction box, the principles of box fill calculations apply. You need to calculate the volume of the box and ensure that the conductors, any devices like splices, and fittings don't exceed the allowable fill. This calculation takes into account the number and size of conductors, the volume occupied by devices, and the volume occupied by any fittings or splices. Thirdly, grounding and bonding, per NEC Article 250, is absolutely critical. The panel must be properly grounded to provide a low impedance path for fault currents. All metallic parts of the electrical system, including the panel enclosure, must be bonded together. This ensures that in the event of a fault, the overcurrent protective device will trip quickly, minimizing the risk of electrical shock or fire. Fourthly, workspace requirements are detailed in NEC Section 110.26. You need adequate clear space in front of the panel to allow for safe operation and maintenance. This includes sufficient depth, width, and height. The specific dimensions depend on the voltage of the system and the configuration of the equipment. The goal is to provide enough room for an electrician to work safely and efficiently. Fifthly, conductor identification and labeling are important for safety and troubleshooting. NEC sections 110.21 and 310.11 cover these requirements. Each conductor must be properly identified as to its purpose, and all circuits must be clearly labeled at the panel. This helps prevent confusion and errors during maintenance and repairs. Sixthly, consider conductor bending space. NEC Section 312.6 dictates the minimum bending space for conductors entering or leaving the panel. This is to prevent damage to the conductors and ensure that they can be properly terminated. The bending space depends on the size of the conductor and the type of termination. Seventhly, for the contactor itself, ensure it is properly rated for the application and installed according to its listing and labeling. The contactor should be mounted securely and protected from physical damage. The wiring to the contactor must be sized appropriately for the load it will be controlling. Eighthly, about overcurrent protection, each circuit controlled by the contactor must have appropriate overcurrent protection, such as a circuit breaker or fuse. The overcurrent device must be sized to protect the conductors and the equipment they supply. Ninthly, regarding the type of conductors used, ensure that the conductors are suitable for the application and the environment in which they are installed. Factors to consider include the voltage, temperature, and moisture conditions. Conductors must be protected from physical damage, such as abrasion or impact. Tenthly, be aware that local amendments to the NEC may exist. Your local jurisdiction may have adopted amendments to the NEC that are more restrictive than the national code. It's essential to check with your local electrical inspector to ensure that you are complying with all applicable requirements. In addition to these code requirements, it's always a good idea to follow best practices for electrical work. This includes using high-quality materials, making neat and professional connections, and testing all circuits before energizing them. Remember that electrical work can be dangerous, and it's always best to consult with a qualified electrician if you have any questions or concerns. Improperly installed electrical systems can create safety hazards and lead to property damage or even injury. A licensed electrician has the knowledge and experience to ensure that your electrical system is safe and compliant with all applicable codes and regulations. Therefore, ensure proper spacing within the panel. Conductors entering or exiting the panel should not occupy more than 40% of the wiring space. Splices and taps should not fill more than 75% of the available space. This ensures adequate ventilation and prevents overheating. Utilize appropriate connectors and fittings. When routing conductors through the panel, use approved connectors and fittings to secure them properly. This prevents strain on the conductors and ensures a reliable connection. Maintain proper separation of voltage levels. If the panel contains circuits of different voltage levels, ensure that they are adequately separated to prevent arcing or short circuits. Use barriers or dividers as needed to maintain separation. Clearly label all conductors and terminations within the panel. This makes it easier to identify circuits and simplifies troubleshooting. Use wire markers or labels that are resistant to fading or smudging. Document all modifications and additions made to the panel. Keep a record of any changes made to the wiring or components within the panel. This helps to ensure that future work is performed safely and accurately. Use a panel schedule to document circuit assignments. A panel schedule is a chart that lists each circuit breaker in the panel and the corresponding loads that it serves. This helps to prevent overloading circuits and simplifies troubleshooting. Keep the panel clean and free of debris. Dust, dirt, and other debris can accumulate within the panel and cause overheating or corrosion. Regularly clean the panel with a vacuum cleaner or compressed air. Inspect the panel regularly for signs of damage or wear. Check for loose connections, cracked insulation, or other problems. Address any issues promptly to prevent them from escalating. Use appropriate personal protective equipment when working on the panel. Wear safety glasses, gloves, and other protective gear to prevent injury. Energize the panel before performing any work on it. Turn off the main circuit breaker or disconnect switch to de-energize the panel before performing any work on it. This helps to prevent electrical shock. Use a voltage tester to verify that the panel is de-energized before touching any wires or component. This ensures that there is no residual voltage present. Follow lockout/tagout procedures to prevent accidental re-energization of the panel. Place a lock and tag on the main circuit breaker or disconnect switch to prevent it from being turned on accidentally. Coordinate with other workers to ensure that they are aware that the panel is de-energized. Clearly communicate the status of the panel to other workers in the area to prevent accidents. Be aware of the potential hazards associated with working on electrical panels. Electrical panels contain live electrical components that can cause serious injury or death if not handled properly. Be aware of the risks and take precautions to minimize them. Seek professional assistance if you are not comfortable working on electrical panels. If you are not experienced in working with electrical systems, it is best to seek assistance from a qualified electrician. They have the knowledge and experience to perform their work safely and correctly. By following these guidelines, you can safely and legally use an electrical panel as a junction box. Remember to always prioritize safety and consult with a qualified electrician if you have any questions or concerns.